about compound statements. So what is a compound statement? Well, a compound statement is formed by connecting two or more statements together. So one example of a compound statement that we've already seen is a conditional statement. Remember that we learned that a conditional statement takes the form if, hypothesis, then conclusion. So if and then is used to combine two statements together. For example, if two lines are parallel being my first statement, then they never intersect being my second statement. So as you can see, I connect two statements together using if and then. So that's what a conditional is, and we looked at that. Now we're going to look at some other types of compound statements. The first one, a conjunction. So a conjunction is a compound statement that uses the word and to join two statements together. So basically we take our two statements, the first being Emily likes to eat sandwiches, the second being Emily likes to eat soup, and we combine those two to create a compound, connecting them using the word and. So it becomes Emily likes to eat sandwiches and Emily likes to eat soup. Or if we wanted to simplify that, we could also do it, and that would look like Emily likes to eat sandwiches and soup. So as long as you have the word and you connect those two statements together, that is a conjunction. And we represent conjunction statements by P, which represents our first statement, this symbol, which looks like a upside down V, which represents our and then Q representing our second statement. Okay. We also have what is known as a disjunction, and a disjunction is again another compound statement, but it uses the word or to join two statements together. So instead of and, it uses or. And here we have two statements, Leah washes the dishes and Jacob washes the dishes. And so if we wanted to connect those two statements together, created in compound statement, we would use the word or. So it would become Leah washes the dishes or Jacob washes the dishes. And we represent this by P and then something that looks like a V, Q. So that's how we would symbolize that disjunction. And like we saw before, you can represent this using Venn diagrams, and so here's an example of that. Whenever we have a conjunction and a Venn diagram, the conjunction, which uses the word and to combine two statements together, will always be represented by the center part. So whatever is located in the center, representing both, would be our conjunction. Our disjunction, on the other hand, uses the word or, and in logic, or means one or both. So therefore, the entire Venn diagram would represent our disjunction. So what happens when we attach numbers to this Venn diagram? Well, I'm going to show you what this looks like, and it's a lot simpler than it looks. Okay. And so here we have an example that uses numbers, and this one says Matilda can what kind of trees people have in their yard. The Venn diagram describes their relationship. So we see here that P represents the number of participants that have oak trees, so this is P. And Q represents the number of respondents who have pine trees. And so what we want to do is we want to identify the number of recipients for which the conjunction is true and the number of recipients for which the disjunction is true. And so what I want to do is I want to identify what this is saying. This says, what is the number of recipients for which P and Q is true? So we have P and Q, this representing and. That is our conjunction. And what we learned is our conjunction is represented by our center part of that Venn diagram. So we'll look at the center. And what we can see there is 600 is located in the center. So the number of respondents would be 600. Okay. Well, what about the other question? This one says the number of respondents for which P or Q is true. So we have P or Q, which represents a disjunction. Remember that disjunction uses or, conjunction uses and. And as we can see here, whenever we have a disjunction being used in logic, that means one or both, so the entirety of the Venn diagram. So when we go over here, we want to look at what number falls entirely in the Venn diagram. And that means what we put these numbers together. And that gives us 1,450. And so that would be the number of respondents for which P or Q is true. Okay? So that's how we would use the Venn diagram with numbers to answer these types of problems. Does anyone have any questions about any of this? Okay, so let's go back. Now we're going to look at another type of compound statement, and that is the conditional statement. A conditional statement can be written as P if and only if Q. So it connects those two statements, statement P and statement Q, together using the terms if and only if. So if P is Jessica is sleeping and Q is Jessica is in bed, well then we can create a biconditional by connecting them using if and only if. So Jessica sleeps if and only if she is in bed. Okay. And we represent biconditionals using this symbol right here, where P implies Q and Q implies P. So we have a double-sided arrow. And because it is double-sided, you can also go ahead and switch those statements. Either way, it's one and the same. Okay. Another unique thing about biconditional statements is that biconditional statements actually can also state the conditional and its converse. So for example, we have P and Q. Jessica is sleeping, Jessica is in bed. The conditional would be if P, then Q. So if Jessica is sleeping, then she is in bed. And the converse, what we learned last time, switches the hypothesis and conclusion around. So it becomes if Jessica is in bed, then she is sleeping. So what does that mean for the biconditional? Well, the biconditional states the conditional and its converse. So what it does is it connects those together using the word and, kind of like a conjunction. So we get if Jessica is sleeping, then she is in bed, and if Jessica is in bed, then she is sleeping. So what that also means is that we can use the different symbols for our conditional and our biconditional, and we can create another symbol for a biconditional connecting them using and. So we have conditional and converse, like that, where that upside down V still represents our and. Okay. Any questions about this? So a biconditional can either be the conditional and its converse, stated and grouped together using the word and, or it can be two statements grouped together using the words if and only if. Either or. Okay. And so now we're going to look at truth tables for biconditionals like we did for conditional, converse, and inverse. And basically, again, I'm not so concerned with you being able to create this truth table. The truth tables will normally just be given to you, but rather for you to identify when is the only instance in when our biconditional is true, and what is the only instance in which our biconditional is false. So the biconditional is false if even one statement is false. So here we have true, true. There's not one statement that's false, so our biconditional will be true. Here we have true, false. Well, we have at least one statement where it is false, and so our biconditional is false. Same thing goes here. We have one instance in when a statement is false, and so our biconditional is false. And then here we have true, true. None of them are false, so our biconditional wouldn't be false because not one of them is false. Okay? And so when is our biconditional true? Well, our biconditional is true if both the statements are either true or false. So both of the statements have to be the same truth value. So true, true means true. False, false means true. But if they are not the same, true, false, or false, true, then it would be false. Okay. Any questions about this? Okay. So what did we go over today? Well, we reviewed conditional statements and the converse. We learned about a compound statement, and then we learned about different types of compound statements: conditional, biconditional, conjunction, and disjunction. And so a biconditional connects two statements using the word if and only if. A conditional connects two statements using the word if and then. A conjunction combines two statements using the word and then a disjunction uses the word or. Any questions about anything we reviewed today? Any questions at all? Okay, if there are no other questions, you guys may log off, and I will see you guys tomorrow. Bye, guys.